Welcome to Chemistry Exhibit at Kalpak 2025. There are a lot of experiments which will help you to explain a lot of chemistry concepts. So let's start with flames. Okay, maybe you have seen a lot of flames. Okay, and flames maybe you can have the flames with different colors basically. So you might have used fireworks, right? So in fireworks, you see different kinds of colors in the flame. So same thing we are going to mimic it, and we'll try to explain why this happens. So I have alcohol with me and a tissue paper. I'm just making two balls of this tissue paper, okay, and I'm going to dip it in alcohol first, and this needs to be done under the supervision of experienced people, elders. Okay, do not try this at home. So I have two pieces of tissue paper dipped in alcohol. So I'll put some salt onto it. So this is a blue color salt which I have, and similarly a colorless salt. Okay, I'll tell you what these salts are, and we'll just put it on flame, okay, and we'll see different colors. So let me first light the blue salt, which gives the green flame, and there is that was a white salt which gave you the uh, crimson red color flame. So this is because actually this is a copper nitrate, and this salt is strontium nitrate. So when copper nitrate is actually put in the flame, copper salts get into the its cationic part and anionic part get separated, and copper gets to the excited state. So when it comes to the ground state, it emits energy, and that falls in the visible region of the green light. Okay, so it is actually you can see a green light coming out of it, of that flame. So color of the flame is green. So in the other case, the strontium actually is there, strontium nitrate. Again, it will go to the excited state. First, the salt will get decomposed, and it will have strontium atoms, and these strontium atoms will get excited, and when they are coming to the ground state, they will emit the energy in the visible spectrum, that is in the red region actually. So you see different colors of the flame. Similarly, in the fireworks, if you know, there are you see observe these flames of different colors, right? I have another experiment just to show you. This is a magnesium ribbon. Okay, usually metal doesn't catch fire, that's what, no, but let me light this and show you. It's take little time because it requires little higher temperature to burn it. Maybe I'll try to polish it some. Maybe the because of there's a deposition of coke, it is not getting burned. We'll try with the high flame. So you saw this this light was white because it was emitting all the wavelengths of the light. Okay, because of that, when we burn the magnesium ribbon, it is at high temperature, it emits all the wavelengths of the light, so it appeared white light.
So today we're going to see a very small experiment. We all know about ferromagnetic substances. One important property about ferromagnetic substances are that these substances are strongly attracted in the external magnetic field. As you can see over here, okay, this is steel. Steel is nothing but it is iron which contains small amount of carbon, and we know that iron is ferromagnetic, and that is why we can see that this steel is getting attracted to this magnet over here. All right. Now, for every ferromagnetic substance, there is a temperature called as Curie temperature. Now, above this Curie temperature, a ferromagnetic substance no longer behaves as a ferromagnetic substance. It shows a paramagnetic behavior. So, as you can see from here, above a Curie temperature, my ferromagnetic substance shows a paramagnetic behavior. So, can we prove this with the help of an experiment? Of course, yes. Let us see. So what I'm going to do is, I'm going to increase the temperature of this ferromagnetic substance, and let us see if it still behaves as a ferromagnetic substance. So you can see that when the temperature is gone above the Curie temperature, my ferromagnetism is lost. My material is no longer ferromagnetic. Now the question is, what will happen when the temperature comes down below the Curie temperature? Will it regain its ferromagnetism? Let's see it. So let us wait for a few seconds. So the temperature is gone below the Curie temperature. Yes, and you can see that my ferromagnetism is retained because my temperature is gone below the Curie temperature. Thank you. Well, Goa. So we all of us we love fireflies, right? Jugnus. And today we are going to see how we are going to prepare fireflies in the laboratories. All right. So for that, what I'm going to do is I have taken concentrated ammonia and I'll pour it in this bottle. Now what I will do is I will shake this thoroughly so that my bottle is saturated with the vapors of ammonia. Okay, so I'll hand over this to Dr. Mithil. He will do the needful. Okay. Now what you see over here is chromium 3 oxide catalyst which we have produced. This is a we have produced this material which has a very high surface area and so that it acts as a catalyst. Hello, Mithil. Cut. Thank you. So, so you have just seen the firefly experiment. Now, how do we get this? So you know that we filled a jar, glass jar with the ammonia vapors. So this is my ammonia over here, and oxygen is there everywhere in the atmosphere. All right, and the powder which was heated in the spatula was nothing but Cr2O3, that is chromium 3 oxide. So this acts as a catalyst. So we know that catalyst is a species which speeds up the rate of the reaction. So we heat the catalyst and we put it in the bottle filled with the vapors of ammonia. So what happens is on the surface of the catalyst, my ammonia gets oxidized to give me nitric oxide. Now this reaction is an exothermic reaction. We know that exothermic reactions are the ones which produces heat. Now because these reactions produces heat, it gives you that firefly effect. So this is how we can make fireflies in the laboratory. Thank you.